Saxon's Trig, lesson 31, on page 211, deals with symmetry, reflections, and translations. So as I have already started with this diagram, if we picture point A here at -4, and this line M is acting as a mirror, then B is a reflection of A in the mirror on the other side at +4. So we would say that A and B are reflections or mirror images of each other. And line M, that whatever is acting as the mirror, is the point of symmetry. So actually M not being the line, but this as point M, that would be considered the point of symmetry. On page 212, they give you these 3 key pieces. If you take an X and you get an answer, and you take a -X and you get the same matching answer, then what you are reflecting across is the Y-axis. So when you interchange the signs on the X, this is your mirror, and you would end up with a parabola-like shape, because if you fold here, or the mirror line would be the Y-axis, you fold over on that, that's where you have interchanged a negative for the X's. Same kind of concept. If you change for a Y value, you change to a negative, then you are reflecting across the X-axis. And so it would look more like this kind of a parabola. If you have a shape that rotates around or reflects around the Y-axis and the X-axis, you have created a point of origin, and you are doing a rotation about origin. I tend to call that a circular reflection. So you've got your Y-axis when you interchange the signs in the X's. You've got your X-axis being the mirror image point when you change the sign on the Y's. If it will accomplish for both, you basically have a circle. Part B now says, let's talk some more specifics about reflections. So, they go through a lot of explanation here. All right, they're giving you examples of numbers, and they're saying, determine whether you are reflecting over the X-axis or the Y-axis, therefore, what kind of a thing do you have? But the key that I'm going to take away from all of that is at the very bottom of the page. If I have f of a -X, that is not the same as saying negative f of x. This is plugging in a negative number into whatever the given function equation was. This is plugging in a positive and then at the end negating the answer. In part C, they talk about translations, and these are the movements that you can make that change a shape. So in our okay, so I guess maybe I'll try to do a little bit more in part B, the reflections. We talked about them here and here. That's why I'm puzzled as to why they're going more in depth. You know what? No, I'm not. Okay, so in section C, the translations, there are 3, and I was looking to see if they listed them for you. It's here somewhere. Okay. I'll try to follow what they're doing basically. If I take a shape, a parabola shape, let's say, and instead of having its vertex point here, I move it up to here, I'm getting the exact same diagram, it's just shifted up. Or I can bring it down, but it's still the same picture, it's slid up or down. I can also slide it right or left, and those, see, maybe they're not trying to give you the terms here yet. I'm going to ignore the terms for the moment. Look at example 1. The graph of the equation y equals root x is shown on the left below. And so that looks like this because they're providing this. Starting dot here, we know that a root is going to graph a curve. So it's going to be, it may not be exact, but that's the general idea. The graph on the right is the same graph reflected on the y-axis. So now what they're showing you is still starting here, but changing the curve to this direction. So instead of here, it's over here. This y-axis is the mirror image, and that's why it's flipping over to here. The graph on the right is the same graph reflected in the y-axis. Write the equation of the graph on the right. Okay. They are not getting into the terms of these. That's why I couldn't find it. What this is asking is, when we said we reflected over the y-axis, we were changing the sign of the x to do the reflected part. So instead of having y equals radical x, we're going to change it to the radical stays the same and the x goes to its negative format. Now I know we're not supposed to have negatives inside the roots. We're not dealing with the fact that that may be creating imaginary numbers. We're just giving them the shifted or altered equation. Example 2, the graph of the equation y equals root x. Okay, so we're going to say that's the same as that picture there. The graph on the right is the same graph reflected in the x-axis. Okay, so now the new one reflected on the x-axis is still starting here, but here's our x-axis, and it looks like this, more or less. There is one other change that they did, but just the reflection part would look like that. All right, the graph on the left is the same graph reflected in the x-axis and translated 3 units to the left. So instead of starting here, it's moving it 3 units to the left, it said. So it's starting it over here and then doing that curve. So this is not the actual picture they provided. Translated to the left. Write the equation of the graph on the right. So we are going to, because we've reflected over the x-axis, we know that we are changing the sign on the y. So where the original was y equals radical x, we are changing this to be negative y equals root x. That fixes the reflection over the x-axis. I feel like I'm drawing that backwards, am I? No, that's right. And then I need to deal with the fact that it translated 3 units to the left. So because that is a movement on the x-axis, the number needs to be attached with the x. And because this root is acting as a parenthesis, so anytime I am plugging numbers or pulling numbers out of a parenthesis, I'm changing their sign. So I moved it backwards 3, but that means in here that's written as a plus 3. Now this is all the parts, but this is not the final way that should look, because it should be in y equals only, not negative y. So that makes this sign over here change outside of the root, because that's a unit stuck together unto itself. So that is the answer for rotating it over the x-axis and shifting it 3 to the left. Example 3. Graph the equation y equals 1 over x. So they're not providing a picture this time. They want me to graph it. Then write the equation of the graph that has the same shape but is translated 3 units to the left and 4 units down. So we are first going to graph this, and then we'll deal with shifting and moving it. So I need to pick some values for x. My first instinct is 0, 1, and negative 1, but 0 I realize is undefined. So in my actual graph, I know that I cannot touch this y-axis. I can't plug in the 0. So this is acting as an asymptote. I can't do the dashed lines, but I know it's going to curve whatever was happening. When I plug in 1, 1 over 1 is 1. When we plug in 2, 1 over 2 is a half. When we plug in, I'm going to do a fraction. Let's do 1/3. So when I plug in a third, 1 over a third, if you want to see that work, is a fraction over a fraction, so the bottom one is flipping. This implies 1 over 1, and it's going to multiply with, flipped over 3 over 1, so that turns it into 3. And then I also need to do some negative numbers. So let's do -1. 1 over -1 is -1. -2 would be -1/2. We can probably figure out, based on what's happening on the positive side, what's happening on the negative side. So we're going to graph, let me do some sections. So 1, 1, I need to put some on the negative side. 1, 1, 2, and only a half up. When I only go over a third, I'm climbing up to the 3. So I can see that I'm not going to cross over the 0 line here. I'm going to keep getting things that go smaller and smaller, a half, a third, a fourth, and so on. So that's going to get closer and closer to the x-axis. This is going to skew up very quickly and continue to climb. So the smaller my fractions, the faster that climb is. Now what happened on the negative side? -1 graphed -1. -2 graphed -1/2. So I've got the same pattern happening closer and closer to the x-axis, and I can determine then, without doing the other number or plug in the other number, that this is going to go very quickly down. So this is the original graph. Now it says take that and translate it 3 units to the left and 4 units down. So everywhere that I had a dot, we are going to do that movement. So that's going to be 3 to the left. 1, 2, 3 to the left, and 4 down. 1, 2, 3, 4 down. So this dot has moved to here. Now I also want to move that asymptote, and you can count it out kind of the same, but I'm going to use it based on where I put this dot. So the asymptote is 1 unit away. So I know that the asymptote moved here should be 1 unit away, and that will land at, working backwards, so that should be here at -3. Okay, so here is my new asymptote line. But I also know that I was being skewed by this axis. So the other way you can do that is to say I'm moving this line 3 backwards. The other was moving 4 down. So I'm moving this x-axis 4 down and creating an asymptote line here. Now that I've moved this dot, I already know that this curvature is matching. And let's move this dot the same so I can get the starting place on the other negative side. So this one's going to go 1, 2, 3 backwards, 1, 2, 3, 4 down, and start here, and then use the new asymptote lines to put that graph in. Now that looks relatively messy because I did them both on the same. You can separate them into 2 separate ones if that is easier than putting them both on the same. Now, did they do anything? Oh no, that was their last example in that lesson.